Number of islands. Let's zoom in. This is an island. 1, 1, 1, 1. Surrounded by zeros. This is an island. Horizontally, or vertically, horizontally, surrounded by zeros. And this is an island. Okay? First thing we need to do is start walking through the grid. So we need for let R equal 0. R is less than rows. R plus plus. For let C, so each row we're going to go down the column. C is less than columns. C plus plus. If grid at RC equals 1, then let's counter plus plus and immediately search recursively all 4 directions. So we'll add a recursive function. And to do this, we're going to need to know the size of our matrix and stuff like that. So const rows is just the number of arrays inside the matrix is the number of rows. So grid.length will tell you that. And to get the columns is every element in the row is equal to the columns. And then define the counter variable. And now define the depth first search. So const dfs equals, and then this, and then this, and you can write your things in right here, your parameters. So my parameters are R and C. Our base case. Every depth base case, and then check for directions. Base case. Mark tile as seen. Okay, so the first is the base case. If R is less than 0, means we've gone too far to the left, or something like that. R is greater than or equal to rows. We're going to use these bars like this. So if any of these things are true, C is less than 0. C is greater than or equal to columns. And finally, the interesting one, grid R C equals, so we don't do anything if it's a 0. Strongly equals. We're going to return. Mark the tile as seen. So we're going to take grid R C and just assign it a 0. Just assign it 0. And now we need to check check all 4 directions. So this is fun. It's my favorite part. You just write the function 4 times, changing it very subtly. So R plus 1, C. R minus 1, C. R, C plus 1. rc minus 1. So you call it for all the directions of the current location. If they're 0, get out of there. If they're 1, change it to 0. And check all the directions. Okay, so bringing it all together. We are walking row by row. If we find a 1, we count it, and then we call this function, which changes it to 0. So we're assigning it 0, not comparing it. And then checking all its neighbors in recursion. It's like a while loop. I don't know. We did not return anything. Very important class is to make sure you return stuff. And not in the main function. We are returning yeah.